Hello everyone, myself Ankit Verma. Today we will discuss our next topic, that is addressing. In everywhere in the computer network, we use the addressing. For example, we have the physical address, logical address, specific address or the port address. These all are the parts of the addressing. For example, I want to develop a LAN or the MAN or WAN. In every case, we need some specific addresses. Also, we need the physical addresses. So we divide the addressing scheme or the set of addresses into four parts. So addresses are divided into four parts. The first one is physical address. We also call it as a link address. Then the second one we have the logical address. Logical address is also called as the IP address. The next one we have the port address. And lastly we have the specific address. Let us take the example of a LAN card. The address written on the LAN card is called the physical address. The address provided by a LAN card, that is the IP address, is called the logical address. For example, the LAN card is using TCP or UDP protocol. That particular protocol address is called the port address, and the address provided to the user, for example, ankit.verma@gmail.com, that is the specific address. Or as we are visiting the website, for example, www.facebook.com, that is again a specific address. Specific address, they have their own meaning and they work on the different layers of the TCP/IP protocols. So let's talk about the TCP/IP model. So in the TCP/IP model, we have four layers. The first layer is the application layer. Next we have the transport layer. Next we have network layer. It is also called as the internet layer. And lastly we have the host network layer. So after each layer we have the specific set of addresses. Just start with the first layer. So at the first layer, that is host network layer, we are using the first address called the physical address. At the network layer we have the logical address. At the transport layer we have the port address. And at the application layer we have the specific address. Now we'll discuss each of the addresses one by one. Let's start the address with the first one, that is the physical address. Physical address is also called as the link address. It is the address of the node that is defined by the LAN or WAN. It is included in frame that is used by a data link layer. It is the lowest level address and has the authority over the network. Now the size and the format of the address depends on the network. So to understand the physical address that is imprinted on your LAN card, let us take the example of a diagram. Before going to the diagram, let's take the example. This example, we are having a particular address in the format like that: 07, 01, 02, 01, 2C, 4B. That particular address is called the physical address, and that address is of 48-bit, that is 6 byte. You can count here. For example, we are talking about the bytes. We have the 6 bytes. 1 plus 1 plus 1 plus 1, and it is equivalent to the 6 bytes. And it is equivalent to 6 into 8, that is 48 bits. So that means the physical address is of 6 bytes or 48 bits address. We can represent the physical address with the 12 hexadecimal digits. So the physical address is the address that is imprinted on your LAN card, and it is of 6 byte address that is represented by 16 hexadecimal form. Now, as the physical address is working on the host network layer of the TCP/IP model, that's why we are skipping all the further layers, that is application layer, transport layer and the network layer. We will only consider host network layer or the data link layer. So now let's draw the diagram. Now here we have a particular bus. We are going to represent a bus topology in which we are having 3 systems. So now in the bus topology we have the 3 systems connected to the bus. The first system is the sender, and the last system is our receiver. And every system has their own physical addresses. As we are talking about the physical address, the sender has the physical address 10, and the receiver have the physical address that is 87, and the mid computer has the physical address that is 28. So here 10, 28 and 87 are the physical addresses. Now to understand how the data will travel from the sender to receiver, take the example of a data packet which is sent by the sender to the receiver. Now this is a data packet which is sent by the sender to the receiver, and whenever the data packet comes to the host network layer or the data link layer, as we have discussed in the OSI model, there is a particular header and the trailer attached to that particular data. So at the data link layer we have added the header as well as the trailer to the particular data. Here H represent as the header and T represent as the trailer. Now, in the trailer, as it is from the data link layer, we will add the T2, the topic we have already discussed in the OSI model. Now, in the header, we will add the source as well as the destination address. These are the physical addresses. Now, the destination address is 87 and source address is 10. So that means we have the firstly the destination address and then the source address. These all are the physical addresses. So now we can see that the physical address, they have their own role in the data link layer. That means in the header we will attach the source and destination address. Now that data packet will send to the particular bus. Now we can see that the data is traveling from the sender. These are the other layers. Other layer, that means the application layer, transport layer and data network layer, because we are not considering the logical and port address. That's why we tell the other layer. Then after that, the data packet is coming to the host network layer, the data link layer. Here DLL stands for the data link layer. Now at the data link layer or the host network layer, we will add a header and the trailer. In the header we have added the source address and the destination address. These are the physical addresses. Now we'll send the particular frame to the bus. Now this particular frame is again sent to or broadcasted to the system number 2, that is the physical address 28, and system number 3, that is the physical address 87. Now the system with particular physical address 28 discard the frame, but the physical address 87 system will accept that particular frame. Now the procedure is same as the sender. At the data link layer, we will receive the particular frame with the header and the trailer. Now we have the particular frame with the header and the trailer. Now when we have the other layers, again the header will be discarded and trailer will be discarded and we will left with the data. Now we can understand the physical address with the help of this particular bus topology. You can see that with the other layers we have sent the data and the data is noted into particular frames, and the frame, the header, we have the source physical address and the destination physical address. In the physical addressing scheme, the destination address comes first, then the source physical address, then we have the data and the trailer. Trailer is basically used for extra bit. These are for error correction and detection. Then this particular frame is sent to the particular bus and the bus broadcasts that frame to the rest of the computers, and the rest of the computers, here we have the 28 as well as 87 physical addresses. 28 will discard that particular frame and 87 will accept, because here we have the destination physical addresses match with the receiver address. Then the data link layer particularly receive that frame, and the other layers will discard header as well as the trailer. Now the data will send to the receiver, that is 87. So now we know the physical addressing scheme. So that's all about the physical address. Now the next one we have the logical address. Now we will discuss the logical address, that is a part of network layer. Well, the logical address is necessary for universal communication. Also, logical address is independent of underlying architecture as well as the physical network. Logical address also provides a universal addressing system that is very unique. Well, all the logical addresses are of 32 bits. Well, now to understand the logical address, let us take the example of a diagram. So, example, we are having two computers. The computer have their own logical address as well as the physical addresses. We are providing as the A by 10 to computer number 1 and B by 95 to computer number 2. Now the first one is our sender and second one is our receiver. Now what is that A by 10? A stands for the logical address and 10 stands for the physical address. Again, P by 95, P is the logical address of receiver and 95 is the physical address of receiver. Now these sender and receiver are connected with each other with the help of router. Now sender is connected with the particular router with the help of LAN 1. Same as the sender, receiver is again connected with the router with the help of LAN 2. Now the main function of router is to divide the particular area into two parts. Now we can see that there is a LAN 1 and LAN 2. That means we are working on the area number 1 and on the other side we are working on the area number 2. So that means these are the two parts of a particular router. So that means the router have two logical addresses and the two physical addresses. So at one side, at the LAN 1, the part 1, the router is having the logical address as well as the physical address F by 20. Here F stands for the logical address, 20 stands for physical address. At the other side, at LAN 2, the router is having T by 99. T is the logical address and 99 is the physical address. Now as we are working on the network layer, that means the logical address is the part of network layer, so we will only consider the network layer as well as the host network layer, that means the data link layer, and we will skip application and transport layer. Now at the network layer we have logical address, and at the host network layer, that is data link layer, we are having the physical address. So we will consider physical address and the logical address in the diagram. So now sender will send the data to the LAN 1. Now the particular data is coming from the other layers, that means from the application layer and transport layer. But whenever the data comes to network layer, we will add the logical address, that means A as well as the P. As we see that A is the address, logical address of sender, and P is the logical address of receiver. Now here we will add the logical addresses because we are working on the network layer. We will add A and P. A is our logical address, P is again the logical address, but A is the logical address of sender and P is the logical address of receiver. That means first is our source and P is our destination. So the source logical address comes first before the destination logical address. Now whenever we come to the data link layer, that is the host network layer, we will add the physical address to the particular packet. Now at the data link layer, we will add the physical address and the particular data. Now our data packet is the combination of logical address plus data. That means AP and data is my data packet, and we will add the header. In the header part, this one is my header and that was in my trailer. As the trailer is of data link layer, that's why we will add the T2 in the trailer. But in the header, we already have the physical address. That means the physical address of particular source, that is 10, and the physical address of particular router, that is 20. So we will add the destination address first, then after the source address, that is 20 and 10. So 20 is my destination address and 10 is my source address. These both are the physical addresses. Now the particular logical address is added at the network layer, and this particular header and trailer is attached at the data link layer. Now this particular frame, which is the combination of header and trailer, is sent to the router. Now we can see that we are having two physical addresses at a particular router, that is 20 and 99. Now the physical address of particular frame will be changed. That is from 20 and 10, it will change from 99 and 95. Because now we are crossing a particular LAN from LAN 1 to LAN 2. Now the frame will become 95, 99 at the header, AP will remain same as the logical address, then data and T2, and that particular frame will be sent to the LAN 2. Now the LAN 2 will send the particular frame to the receiver in the same fashion as we have discussed from sender to LAN 1. Now the frame, the modified frame, is sent from LAN 2 to particular receiver. So that is the particular way by which, with the help of physical address and the logical address, we can send the data from sender to receiver. But the important point to note here that the logical address will remain same. You can see that in the particular data packet we have the AP, that is same as the data which is sending. So that means the logical address is always remain same. We also call the logical address as the IP address, but the physical address will change with every router. Now you can see that in the particular frame which was sending to the LAN 1, the destination address and the source address of the physical was 20 and 10. But now when we send the particular frame from LAN 2 to receiver, when it is coming from LAN 1 to LAN 2 with the help of router, the physical address changes. That is now 95 and 99. So that means the physical address will never remain same, but the logical address is the unique and follow the universal standard and will always remain same. So that is all about the logical address. Now the next we will cover the port address. Port address comes at the transport layer. Now the port address, why we need the port address? See, we know that the physical address always change, that is imprinted on the LAN card. Logical address is our IP address which never change. But what is the port address? For example, we are using a TCP and UDP or maybe the Telnet or FTP protocol at particular sender and receiver. Now we are not sending the data from sender to receiver, we are not focusing on particular data. We are sending the particular protocol, data which comes from the protocol. That means from TCP to TCP, or from UDP to UDP, or maybe from telnet to telnet. That means now it's not the sender or receiver. We have divided the mainstream into particular parts of the protocols. There we require the port address. So to understand the port address, let us take the example of a diagram. Next we have the port address. Port address is the part of transport layer, and port address is of 16-bit. All of us know that the physical address and the logical address is necessary for data to travel from source to destination, but that is not the end objective. So what's the end objective? The end objective is to process communication. To understand process-to-process communication, let's just take the example of a diagram. So example, we have two computers. I am providing them the name as C1 and C2. Now, C1 have two processes, or maybe the two protocols, that is Telnet and FTP. Same the system number 2 have the two protocols, that is Telnet and FTP. Now, the process, that is the protocol Telnet of system number 1 wants to communicate with system number 2. Now, at the same time, the FTP protocol of system number 1 wants to communicate with FTP protocol of system number 2. So now we have the single path between two systems, but there are different protocols which wants to communicate with each other at the same time. So that's why we need a different process number, or in the layman language we say we need a different port numbers. So that is the invention of port address. So we provide the different addresses to particular ports. So Telnet have a different address that is called the port address, that may be the I, and the FTP have a different address that may be the J. So these are port addresses. Here P stands for the port address. Now to understand the complete port address or the transport layer function, let us take the diagram. Before going to the diagram, see, we are discussing the port address which is at the transport layer. That means the above application layer is the other, and below we have the network layer as well as the host network layer. That means we will also consider physical address as well as the logical address while doing the work with port address. So we will make the diagram now. Now, for example, we are having two systems. One is the sender and one is receiver. Now S is my sender and R is my receiver. They both have different protocols or different processes with them. So example, S is having three processes. Now these are the three processes which are used by the sender, and we are providing them the name as P1 as the process 1, P2 as the process 2, and P3 as process 3. Now I am providing the particular port address to each of the process. So example, I is provided to process 1, J is provided to process 2, and K is provided to process 3. Now this one is the particular port address. Now here PA stands for port address. So that means I, J and K are the port addresses. Now again receiver have two processes, that is P4 and P5. Now the name of processes are P4 and P5. Now processes 4 and process 5 have their port addresses, that is A and B. Now sender and receiver are connected with each other with the help of internet. Now sender will send the data via internet to the receiver. Now for example, process 1, that is the port address I, wants to communicate with process 4, that is port address A. Now as you know that the port address is part of transport layer, that means the other layers, the application is part of other layer. Now data packet will come from the application layer. Now from the application layer, data will come to the transport layer. That means we will add the particular port address, because at the transport layer we are having the port address. So we will add the port address as the header in the data at transport layer. Now this one is our transport layer, and at the transport layer we will add the particular header with the data, and in the header we will attach the port address. The port address is of source and destination. Now the source port address is I and destination port address is A. So we will add the source address first. the source port address is I, and then we have the destination port address, that is A. So here source port address comes first, then after that we have the destination port address. Now the complete packet will come to the network layer. In the network layer we will add the further logical address to the data packet. Now this one is our network layer, and at the network layer we will add a particular header with the data. Now the data coming is I, A and data, and we will add the header as the prefix. And in the network layer basically we add the logical address. Now the logical address of system we will provide. Now say example, source is having the address that is A. Now A is the logical address of the source, and of the receiver we are having the logical address that is P. Now A is the logical address of source or maybe the sender, and P is the logical address of receiver. Now LA stands for logical address. So now we will add the particular logical address, that is A and P, source and destination, to the header at network layer. So we will add the source logical address first, that is A. Then we will add the destination logical address, that is P. That means source comes first and the destination logical address comes after that. Now that particular packet will be sent to the data link layer or host network layer. So next we come to the data link layer, in which we have the concept of framing. Framing, that means we will add a particular header as well as a trailer. Now here we have the header of the data link layer. Data link layer is the second layer, that's why we will add the header as H2. Now here H stands for header and 2 stands for the data link layer of host network. Now we will add the trailer at the end of the frame, that is T2. Now T stands for trailer and 2 stands for again the data link layer. So that is all about. Now we have a particular frame with the header as well as the trailer. Now this particular frame is sent over the network, and network will pass on the particular frame to the receiver. Now the internet will send the particular frame to the receiver in the same fashion. Now again at the receiver side, the data link layer receiver frame that contain the header, logical address as well as the data and the port address. Now that particular address and the frame is passed to the network layer. The network layer discard the header as well as the trailer and then forward to the transport layer. Now the transport layer again discard the header and contain the data only. Now the only data is taken by application layer and passed on to the receiver. Now the receiver will pass on that particular data of the process P4 by the help of port address. So that is all about the port address. Now the main thing, the source address comes first of port address before the destination. Again one more thing, the physical address changes from hop to hop, but logical and port addresses usually remain same. So that is all about the port address. Now the next is specific address. Now next we have the specific address. Specific address are present at the application layer. Now we have the few applications which are very user friendly and they use the user friendly addresses. So we call them as specific address. So we can say that specific address are the user friendly addresses. User friendly addresses, that means the user can understand very easily. As we know that the physical address, logical address and the port address are of system use. That means the physical address that is imprinted on the particular LAN card, logical address is the IP address and the port address is the port number. Now we have the specific address that is understood by the user. That means maybe any website. For example, we are having a URL. URL means Uniform Resource Locator. That means we open a particular website that is called the URL. So example of the URL is, that is example www.facebook.com/smartnames. So that may be any email address. An example like ankit.verma.aquarius@gmail.com. So that means any of the URL just like www.facebook.com/smartmates or maybe any of the email address, just like ankit.verma.aquarius@gmail.com are the particular specific addresses. The specific addresses get changed to corresponding port and logical addresses by sending computer. So we have discussed the specific address, just like the URL, the email ID. Now we have discussed the addressing scheme, in which we have the four different addresses. The first one is the physical address, which is imprinted on the network interface card. It is of 48 bit, that means 6 bytes. The example of the physical address is 07.01.02.01.2C 4B. So that is the 12 hexadecimal digits address. This is the physical address. Now next we have discussed the logical address, which is of 32 bits, and then we have discussed the port address, which is of 16 bit. That may be any of the numeric decimal, just like 753, and the specific address may be any URL or email ID. So that is all about the addressing scheme. Thank you.